Dear students of 9th standard, welcome to Say No to Maths. We are doing the chapter Quadrilaterals, exercise 8.2. Let's go to question number 4. Let me read the question. ABCD is a trapezium in which AB is parallel to DC, BD is the diagonal, and E is the midpoint of AD. A is a line drawn through E parallel to AB, intersecting BC at F. At this point, F. This is line BC. Now, the question is, F is a midpoint of BC. That means we need to prove that these two parts are equal. We have to prove that these two parts are equal. So, let me start with the question. We know that ABD, A in triangle ABD, E is the midpoint, and you are drawing a line parallel to the second side. Then it will bisect the third side. Let us take this point as G. Let me mark it as G. So, G is the midpoint. This is the converse of the midpoint theorem, right? G is the midpoint of, that means DG, BD, that means DG is equal to GB, right? Now, let me now get back to other triangle, other part of the triangle. Now, let me take triangle B, C, and D. Let me take triangle BCD. In this triangle, already G is a midpoint. It is upside down. Try to look it from the other side. Yeah, it is already G is the midpoint of BD, and EF is parallel. It is parallel to AB. So in a trapezium, what do you understand? That AB is parallel to DC. One set of sides are parallel. So therefore, EF, which is parallel to AB, EF will also be parallel to DC because AB is parallel to DC. So, what does this mean? In triangle BCD, G is the midpoint of BD and there is a line drawn parallel to DC. Then the converse of the midpoint theorem says that the point F, where it meets the third side, it bisects it. That means CF is parallel to FB. CF is parallel to FB. CF is equal to FB. That means F is the midpoint of BC. Let me go to the 5th question. Let me read the question first. In a parallelogram ABCD, E and F are midpoints. Point E and F are the midpoints. E and F are the midpoints, okay, of side AB and CD. Show that the line segments AF, where is AF? Join this and this. This is AF and EC. They are not diagonals. Yeah, remember they are not diagonals. So AF and EC trisect BD. We have learnt about what is bisect. What is this trisect? Tri means 3. Sects are parts. It divides, BD is divided into 3 parts. Okay, let me go to the triangle. Now in this, first of all, ABCD is a quadrilateral. In this quadrilateral, AB is equal to CD. E and F are midpoints, right? Now, E and F are midpoints, right? So when you say that total AB is parallel to DC, now their parts will also be parallel, right? That means AB is parallel to CF. Now here it's a midpoint. This part is equal to this. AE is equal to EB. Now similarly, DF is equal to FC, but opposite sides in a parallelogram are already equal. So these parts AE, EB, DF and FC are equal to one another. That means all those small four parts are equal to one another. So first of all, we can prove that AECF is a parallelogram. But that's not what is asked in the question. The question asked is AF and CE or AF and EC trisect diagonal BD. Right. So let me take the triangle. First of all, let me take the triangle DC. Let me erase these lines so that there's no confusion. Now, DCQ. Where is DCQ? DCQ. DCQ. Yeah. In this triangle, now F is the midpoint. Yeah, since it is a parallelogram, FP is parallel to CQ. So what do you say? P will be, when it is parallel to one side and it is the midpoint of one side parallel to the other side, then it will always bisect the third side. That means DP is equal to PQ. One part of the question, two pieces are equal. Now the third part should also be equal. So what do we do for this? Let me take the triangle. Let me take the triangle. Now APB. Let me erase this. Yeah. Let me take the triangle APB. Now in this, yeah. So in this, already AE, E is the midpoint, right? E is the midpoint. It is parallel to the second side because AECF is a parallelogram. So it will always bisect the third side. That means Q is the Q bisects BP. That means this part PQ is equal to QB. Already DP is equal to PQ. Now PQ is equal to QB. So DP is equal to PQ is equal to QB. They are divided into three equal parts. That means AF and EC trisect the diagonal BD. Hence it is proved. Thank you very much, children. Hope you are understanding. If you have any doubts in any other chapter also, please put it in the chat box or to my personal WhatsApp. Thank you.